Hey there, my name is Alejandro, and welcome back for day 22 of me doing the Advent of Code December 2024 challenge. So today we get the problem, Monkey Market. As you all teleported deep into the jungle, a monkey steals the historian's device. You'll need to get it back while the historians are looking for the chief. The monkey that stole the device seems willing to trade it. Well, only in exchange for an absurd number of bananas, of course. Your only option is to buy bananas on the monkey exchange market. You aren't sure how the monkey exchange market works, but one of the historians senses trouble and comes over to help. Apparently, they've been studying these monkeys for a while and have deciphered their secrets. Today, the market is full of monkeys buying good hiding spots. Fortunately, because of the that's what they're buying. Okay. Fortunately, because of the time recently spent in this jungle, you know lots of good hiding spots you can sell. If you can sell enough hiding spots, you should be able to get enough bananas to buy the device back. Greedy monkey, mate. Greedy monkey. On the market, the buyers seem to use random prices, but their prices are actually only pseudo-random. If you know the secret of how they pick their prices, you can wait for the perfect time to sell. I see. The part about, I hope this doesn't mean to start using machine learning to like predict and so on, because I don't know machine learning at all. Okay, the part about secrets is literal, but the historian explains. Each buyer produces a pseudo-random sequence of secret numbers where each secret is derived from the previous. In particular, each buyer's secret number evolves into the next secret number in the sequence via the following process. Oh, they tell you the process. Okay. Calculate the result of multiplying the secret number by 64, then mix this result into the secret number. Finally, prune the secret number. What does prune mean? Calculate the result of dividing the secret number by 32, round the nearest, okay, then mix this result into the secret number. Finally, what does prune mean? Okay. Calculate the result of multiplying the secret number by 2048. Then mix this result into, finally prune the secret, what? Okay. Each number, I hope they give an example. Okay, they probably will, right? Okay. Each step of the above process involves mixing and pruning. Oh, okay, they tell you what mixing and pruning is. Okay, to mix a value into the secret number, calculate the bitwise. Okay. Calculate the bitwise XOR of the given value and the secret number. To mix a value, okay. Calculate the bitwise XOR of the given value and the secret number, then the secret number becomes the result of that operation, and the secret number is 42, and you were to mix 15 into the secret number. Then your secret number would become 37. Okay, we're going to have to find a way to essentially reverse engineer this process, right? Where it's like, okay, multiply, then probably divide. Okay. To prune the secret, so we gotta, if they're reversible operations, then we're chilling, right? To prune the secret number, calculate the value of the secret number modulo, holy crap. Okay, so this means that we're probably gonna reverse engineerable, but there's gonna probably be like multiple values that are possible, and we're gonna have to keep searching for ones that are, or something like that. Okay, because yeah, we're gonna have to like keep looking at like multiples of something. Yeah, okay. Then the secret number becomes the result of that operation. If the secret number is 1 million, and you were to prune the secret number would become, okay. So if I do this, let's open up the terminal. What the heck? No, I want to do Python 3. I want to do this number modulo whatever this guy is. It would be, 16. Okay. So yeah, so the point is, after this process completes, the buyer is left with the next secret number in the sequence. So yeah, if a buyer had a secret number of 123, that buyer's yeah, the buyer can repeat this process as many times as necessary to produce more secret numbers. So if a buyer had the number 123, the buyer's next 10 secrets would be blah, 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 blah. We can write our own function to compute this. Each buyer uses their own secret number when choosing their prices. So it's important to be able to predict the sequence of secret numbers for each buyer. Fortunately, the historian's research has uncovered the initial secret number of each buyer. Oh, so there's not going to be any reversing. You just apply the process. What? Okay. Well, you're given the initial secret number of each buyer, so the problem isn't going to be find the secret number? Okay, this list describes the initial secret number of 4 different secret hiding spot buyers on the monkey. Okay, if you can simulate the secret numbers from each buyer, you'll be able to predict all of their future prices. Okay, in a single day, buyers each have time to generate 2,000 new secret numbers. In this example, for each buyer, adding up the 2,000 new secret number for each buyer. So we want the 2,000 secret number for each buyer. But 2,000 is such a low number. Can we not just brute force this? Okay, for each buyer, simulate the creation of 2,000 new secret numbers. What is the sum of the 2,000th secret generated by each buyer? Okay, so what I'm going to take away from this is that for part one, it's just going to be a brute force this kind of thing. That way it's like, you know, you have a working script, and part two is going to be something insane. Part two might be, you know, reverse engineer or so on. It legit might. Okay, we'll see. Okay, let's open up the GitHub desktop. Okay. Let's do it. Okay, here we're gonna open in Visual Studio Code. I'm so glad that I'm done with problem 21. I was really scared for that problem because I saw the leaderboard rankings were like, you know, more than double than ever before. I was like, oh gosh, what abomination is gonna be day 21. So yeah, glad to have finally finished that one. Okay, so here we'll put in a data.txt. Here we'll put, okay, a test data.txt. Here we'll also put a part1.py. Okay, get your puzzle inputs. Okay. Oh my gosh. Okay. That's a few numbers. Okay, so that's 1,600. Okay. And then for test data, and we'll get this, right? And so essentially we want to build a hash map. Okay. Yeah, test data is only a little smaller than the normal data. Okay, part one. Whoops. Okay. Okay. So here what we want to do is in part one. So we've got. Oh wait, what? Oh no, I pasted this by accident in part one. But I want to put it in my data.txt. Okay. So yeah, so let's close this. Here we'll do use test data is equal to true. File name is equal to /data.txt. If not, use test data, else /test data.txt with open file name, read mode as file. Lines is equal to int of line.strip for line in file.read lines. Print f string lines equals. Let's do cd dot into 22. Let's kill this stuff. Bring this back. cd into 22. Python 3 part1.py. Okay, so yeah, so now we have our things nice and clean. So if we put false here, it needs to load a bit, but yeah, there we go. Okay, and 7435529. Yeah, so we get the last one nice and crisp as wanted. Okay. Noise. So yeah, we can put this back to true, and there we go. So we have 1, 10, 100, 20, 24, right? So def get next secret number. Right? So that's what we need to do. Involves this next secret number in the so calculate. So yeah, so here new secret res is equal to secret number times 64. Then mix this result into the secret number. Wait. Okay. Mod 64 is equal to times 64. So here we'll do mix of num1, num2. To mix a value into the secret number, you turn num1 XOR num2. Is that what it is? Yeah, 42 and 15. If I do 42 XOR 15, then yeah, I got 37. Okay, so return, so mix, there we go. So def, what about prune? Prune, num, modulo this. Okay, return num modulo this guy. So, okay. All right, we tried this. All right, this guy modulo this guy is, yeah, 16, yeah, okay. For now I'm kind of weirded out. The problem is like a little bit too easy. So yeah, let's just keep going. It's just, okay, so part two, actually, okay, we'll see. So yeah. Res is equal to mix, or no. Prune. Okay, mix. You mix the secret number as well as the secret number times 64. Also, if we do times 64, wait a minute. We gotta be careful. There's gonna be some aspect of cleverness, right? Because this is what? 2 to the what? 2 to the 4, 2 to the 5, 2 to the 6, right? So it's like shifting 6 bits. Right? Which means that on the right is going to be zeros. So it's going to keep those, and there's like, yeah, there's going to be some weirdness going on, right? Bin of 37. Bin of 42. Bin of 15, right? These aren't really that innocent. But yeah, bin of 42 XOR 42 times 64. Bin of 2730. Yeah, there's some weirdness going on here. Yeah, you see what I mean? Where it's like it continues its pattern. It's gonna be one of those kind of things. Well, I mean, for now this is just fine, right? But yeah, we might be able to make it like, you know, non-linear or whatever. So we need to prune this. Calculate the result of dividing the secret number by 32. Round the result down to... Okay. Each binary secret number evolves into the next secret number in this... Yes. Okay. Okay. Calculate multiplying the number by 64. Okay. It's confusing how they do this. Times 64. Then mix this result into the secret number. So secret number is equal to mix of secret number as well as calculate. Secret number is equal to prune of the secret number. Right? Result, so calculate is equal to secret number divided by 32. Down to the nearest integer. Wait, is it down to the nearest integer? Or to the nearest integer? I'm going to assume that this means round down. So down. Then mix this result into the secret number. Secret number is equal to mix secret number and calculate. Finally, prune the secret number. Secret number is equal to prune of the secret number. Okay, calculate is equal to secret number times 2048. And mix this result into the secret number. Secret number is equal to mix of secret number, comma the calculate. Secret number is equal to prune the secret number. Right? Return secret number. This is step 1. This is step 2. Step 3. Finally, return your secret number. Okay, so get secret number. So yeah, nice. So now print get secret next secret number. Okay. Of secret is equal to 1, 2, 3. Secret number is equal to 1, 2, 3. It's in range 1, 2, 10 equals print f string secret number. Yeah, okay, we get the exact same result. Okay, we'll do this. Range 2000. Okay. That string secret number. Get kth 2000. Get kth secret number k. Get k secret number. Assert k is greater or equal to 0. In range k equals get next. I don't like this is not too slow, right? Like this is technically like O of 1 operation. Like we've done way more insane stuff, and I can also just wait. Like if okay, I'm just okay. So far, I'm not. Don't feel scared. Get k secret number, you know. Secret number, right? So here's like print f string, you know, get k secret number. We'll do 1 and 2000, right? There we go. So here d is equal to num comma 2000 for num in lines. Print f string d equals. So 1 maps to this, 10 maps to the 4700. Okay. Okay. Print f string answer is equal to sum of d dot values. Right? Or better yet, we'll just do res is equal to sum num comma 2000 for num in lines. Print f string res. Here I get this number. I'm not tripping, right? 32327 Okay. Okay, let's get rid of this. Let's get rid of this. 37327 Okay, let's just put false, I guess. Okay, so it's too slow. Oh no, it's not. We have it there. Okay, let's put in the answer. Okay, that's the right answer. You're one gold star closer to finding the chief historian. Continue to part 2. Okay, so far I'm confused, but I'm gonna guess that part 2 is probably some insanity brainiac problem. So hit me, let's see what you got. All right. Of course, the secret numbers aren't the prices each buyer is offering. That would be ridiculous. Instead, the prices the buyers are just the ones digit of each of their secret numbers. So if a buyer starts with a secret number of 1, 2, 3, That buyer's first 10 prices. Bro, what? Okay. Where the secret number 1 to 3, the buyer's first 10 prices would be, okay, the last number. This price is the number of bananas. Okay, so this is what I mean by, there's going to be some efficient competition, right? Because it's like you only care about the last digit and so on. Okay. Like it's very sus to XOR with a power of 2, right? You know what I mean? Of the same number. Oh, plus, yeah, it's very sus. Okay. This price is the number of bananas that the buyer is offering in exchange for your information about a new hiding spot. However, you still don't speak monkey, so you can't negotiate with the buyers directly. The historian speaks a little, but not enough to negotiate. Instead, he can ask another monkey to negotiate on your behalf. Unfortunately, the monkey only knows how to decide when to sell by looking at the changes in price. Specifically, the monkey will only look for a specific sequence of 4 consecutive changes in price. Then immediately sell when it sees that sequence. So if a buyer starts with a secret number of 1, 2, 3, that buyer's first 10 secret numbers, prices, and the associated changes will be 3. Okay, so you went to 0, which is negative 3, 6, negative 1, negative 1, 0, 2, negative 2, 0, negative 2. Note that the price has no associated change. Okay. In this short example, within just these first few prices, the highest price will be 6. So it would be nice to give the monkey instructions that would make it sell at that time. Wait, what? Only look for a specific sequence of 4 consecutive changes in price. Okay. So it would be nice to give the monkey instructions that would make it sell at that time. The first 6 occurs only after 2 changes, so there's no way to instruct the monkey to sell then. But the second 6 occurs after the changes negative 1, negative 1, 0, 2. Oh, so this was the change. Okay. Well, so we can make this a little bit better, right? Okay, let's go into part 2. Right, here we'll say 22 dash part 1 complete. I want to do part 2.py. One thing I want to do is import time. That's time dot stopwatch or start time equals this. Print a string time equals time dot time minus start time seconds. Okay, So that took 1.8 seconds. 1.8 seconds. So yeah, let's put that in part 1. And import time. Part 1. It's just choosing to take a little longer now, but yeah. But now what we'll do is we'll make this a little bit better. Here we'll cache this. First of all, if we cache this, okay. Here I want to call this rename to part 1 dash efficient. So let's take part 1 here. Let's paste it in here. Why is it taking 2 seconds all of a sudden? Okay, oh well. Right, if we put it, oh well, it is what it is. Okay, but now, first of all, if I put a cache out here, probably not much happens, right? Maybe a little bit, but not much. In fact, it's a little bit slower. Here, however, if I do this, it's much slower because it needs to make the memory for it. But now, return secret number. Okay, cache, can't. Can't recurse more than 1,000 times. Okay, I guess I can't even do that in Python. No worries. Okay, I thought I could be clever there if I start caching some results. Right? But yeah, this is O of 1 time anyways. This is all O of 1 time anyways, so like caching and so on, yeah, it's all O of 1 anyways. Okay. It's O of 1 anyways. Okay, so let's stop worrying about that anyways. So yeah, this we can rename to part 2. It's fine. So we gave them money that sequence, yeah, we wait until this sees. So basically, I want to do 6 bananas. Okay, each buyer only wants to buy 1 hiding spot, so after the hiding spot is sold, the monkey will move to the next buyer. If the monkey never hears that sequence, so if after the hiding spot is sold, the monkey will move on to the next buyer. If the monkey never hears that sequence of price changes from a buyer, the monkey will never sell. Just move on to the next buyer. Worse, you can only give a monkey a single sequence of 4 prices changes to look for. You can't change the sequence between buyers, okay? You're going to need as many bananas as possible. So you need to determine which sequence of 4 prices will cause the monkey to get the most bananas overall. Oh gosh. Each buyer is going to generate 2,000 secret numbers after their initial secret number. So for each buyer, you'll have 2,000 price changes in which your sequence can occur. Suppose the initial secret number, yeah, okay. There are many sequences of 4 price changes you could tell the monkey, but for those 4 buyers, the sequence that will get you the most bananas is this one. Using that sequence, the monkey will make the following sales. Changes, the price is 7. So essentially, what I need to do is a rolling thing, right? I need a sliding window. basically for of length 4 every single time, and be like, hey, this one like if I gave it this and this, the monkey would do 7 here and this here and so on. Right, so essentially I needed, for a secret number, I should give all 2000, there's only like 2000 or 1996 possible 4 sequence numbers. As long as they're all unique, there's only at most like, 1996. And for each one I should give the price value, right? And then in total you have like a set of all of them total, and it's just like, okay, out of all of them, give me the maximum 1. This isn't that hard. Okay, for the buyer with an initial secret number of 1, changes 2, 1, negative 1, 3, first occur when the price is 7. For the buyer with initial secret 2, yeah. So we can use a default dict if anything. Yeah, okay. Yeah, this is super straightforward. This is super straightforward. Okay, yeah, this is. I thought we were gonna have to probably like reverse engineer for part 2. Yeah, this is just okay. Okay, it's just a little bit annoying, but like yeah. So like I need to build a window, right? New secret number changes is equal to, or deltas is equal to this. Deltas dot append new secret number minus secret number equals new secret number. Secret number deltas and deltas, right? I'll say also we can do def get next secret number optimized secret number return. Here we can do secret number equals XORed with secret number shifted by power of 2, 6 by 6. Or if I do 7 shifted by 6, 7 times 64, yeah. This will be modulo this value. Secret number is equal to mix of XOR with secret number over 32, which is really the same thing as what? 8 divided by 32. If I do 450 divided by 32, I do 465 divided by 32, okay. 465 right shift by what? 3? 4? 5? Oh, 2 to the 5, yeah, 2 to the 5. Yeah, so this should be right shift by 5, and then modulo this. Modulo this by 2048, 2 to the power 10, 11, 2 to the power 11, 2048 times 17, 17 shifted by, shifted 11, yeah, equals secret number XOR with secret number shifted 11 modulo this, return secret number, return that, right? So we'll do get k secret number is the same one from here. Number optimized. Okay, so here we'll do Python 3 part 2.py, and the answer we got was this about, yeah. Now if I do optimize, is it a little bit faster because of the function call stuff? Yeah, it's almost nearly twice as fast, right? Yeah, it's a lot faster. So yeah, let's just do it that way. So yeah, no need for these functions. It's just additional overhead that is completely unnecessary. Okay, cool. Cool. Even though it's O1 stuff, again, anything that we can get. And this is sus, right? XORing, which is based off bits, where you essentially shifted these bits like this, is giga sus. Here we don't even need to call this optimized. Small optimization for getting next secret number logic to do something. There's something sus. Also, is this a power of 2? Is there a log function? Math.log, import math. From math, import log. Log 10, base 2. Base 10, yeah. Log base, this number, base 2. Okay, that's giga sus. See, this is like giga sus, right? Let's see. So yeah, bin of this number is just a single bit, right? So I only care about the last such bits. I don't know, there's something sus about that to me. I mean, I don't have to worry about that, but it's just, that makes it sus for me. There's something suspicious about that, right? Like, I'm not crazy. There's something mega suspicious about that. I don't know if it'll start helping me out, but like, there's something just overly sus. They're all perfect. They're a little too perfect, right? It's like they're a little bit too perfect here. Length of this here we'll say magic number with this number is equivalent to modulo the power 24. At 2 to the power 24. So if I take this number, right, that they gave us, right, this modulo, this guy gives that. If I take this number and I AND it with this magic number, no. Why is it not the same? Oh, maybe I want this times 24. Okay. Makes sense. Makes sense. Yeah, actually that makes perfect sense. That makes perfect sense. So it'll be this minus 1. And magic number. And magic number. And magic number. It's just as fast. There's something sus, right? Import random for this in range 10. Number equals random.randint from this to whatever. Print. See, like this pattern repeats. There's something sus. 1, 2, 3, 4, 5, 6. I don't know. There's something suspicious going on, but for now I'll just let it be, right? Right, for this, where's the perf of this? 1.19? Where's the perf of this? 1.17. Okay, we'll just say that this wins for now, but barely. Okay. Sus activities, I'm just saying. Some sus activities. Some very sus activities over here, ladies and gentlemen. Okay. Def get next secret number. We'll just, there we go. More optimized version. Get next secret number logic from part 1. There we go. So yeah, if we ever need this function, there we go. Right. So let's see. Here there's a sequence that starts there. So what we want, secret numbers. Secret numbers dot append new secret number. Return. Case. So here let's do secret numbers deltas is equal to get secret numbers and deltas 1, 2, 3 up to 10. Print f string secret numbers equals print f string deltas equals, and for now we'll just start like exiting the program. We'll do string -1. And this is an int. This is kind of expensive, but oh well. 0, 6, 5, 4, 4, 6, 4, 4, 2. Get price from secret number. Secret number. Return. Old price, comma new price equals secret number, get price from the new secret number, new price minus old price. Dot append new price. So yeah, so 0, -3. Third length of secret numbers equals length of deltas in range length secret numbers with f string it should be renamed at prices and deltas. Prices prices deltas of I. So yeah, here we have 0, -3, 6 and 6, -1, -1, 0, 2, -2, 0, -2. So essentially, for every secret number, we should get the prices and the deltas, right? And then what we'll do is we'll sliding window for every subarray of length 4, make that a unique sequence. If anything, we should do a rolling hash. How do we do a rolling hash? Kind of like Robin Carp, right? I guess I can just I can convert it into a tuple, because it's just 4 elements, right? Yeah, because I want something unique. It's 4 elements anyways, right? So I can use a list, and every time I convert to a tuple, and it's 4 elements, it's an O of 1 operation. Okay. Right now I'm purely code mode. Right? Def compute prices, comma deltas. Assert length of prices equals length of deltas, n equals 4 I in range n. So delta window deltas the first 4. If length of deltas is 4, return. Moreover, assert length of deltas greater or equal to 4. So we have 0, 1, 2, and 3. Right? We want to consider this as a valid and then update the window. For R in range, so we have 0, 1, 2, and 3. So we want to do 4 length of num of 4 to n. Add current window. D is equal to this. We're gonna get this. We're gonna get this. We're going to do this. This is going to be simple. We just need to code this up. We just need to code this up. This is going to be simple. We just need to code it up. That's all. That is literally all. Oh, we can drink some water. It's going to be a very straightforward problem. Is equal to a collections.deck of this. Yeah. Pop left. Delta append. deltas of R. At current window, this would be default dict event. It'll be the first sequence it sees, right? Yeah, it'll be the first sequence it sees. Pro window equals tuple of window. Here we'll do is equal to set window not invisited, invisited.add tuple window, so it's only the very first, so the monkey will only grab the very first one that it wants. And here we'll do d of tuple of window plus or equal to, well here for example, we'll have -1, 0, and 2, right? So at this, so like for example, we're now at 0, 1, 2, and 3. Just gotta make sure I initialize my stuff real quick. Maybe we can make our window up to the first 3. Window.append left. Garbage to be deleted immediately. Update the window. Append deltas of R, right? So at the very beginning we'll have 0, we'll have -3. So the beginning we'll have garbage, -3, 6, and -1. So we'll pop the garbage and we'll add this -1. So then we have -3, 6, -1, -1. And this index 4 is the price that it corresponds to, right? So if tuple window is not invisited, then add that into visited into d of tuple window plus or equal to prices of R. So here, we'll grab this stuff, print f string, compute, prices, comma deltas, print f string d equals, print f string d equals. So -3, 6, -1, -1 will have a price of 4. 6, -1, -1, 0 will have a price of 4. -1, -1, 0, 2 will have a price of 6. So for each of these, it'll be the very first time the monkey sees. And if a sequence repeats, which I don't think they have any repeating sequences in here, it'll ignore it, right? Because it's only if the thing is not visited, right? And if it isn't, it'll be immediately visited, right? Because the monkey will only do the very first sequence that it sees. So essentially, what I want to do is here, what I want to do is we'll put use test data is equal to true, first of all. Okay, that is the exact answer. Good. Nothing's not working. Yeah. For secret number in lines, we'll do prices, comma, deltas. The secret number in 2000s. Here we won't do anything. F string d equals. F string max of d dot values equals 24. You get 23. I said that there's a way to get 24. Is my VS Code frozen? Uh-oh. Uh-oh. Okay. Okay. -9, -9, -1, 0. Holy crap, this is slow. That one, it says it gets 16. Interesting. Zero, 1, 2, and 3. Very first three deltas. Visited as unique here. That's interesting, right? Here what we should do is we'll make a notification, we'll make this a list. And here we'll make this of tuple window that append prices of R. So we should be careful. Wait. 0, 1, 2, 3. Here this will be 0, 1, 2, 3. No, that's good. Here we want to do d of seven, then 7. This should do every single thing. It's just not the change we need. Oh. Wait, so we don't know to stop at 2000. No, you do stop at 2000. Maybe 2000 plus 1? Plus 100? That's 10,000. 739. It's nonsensical. I don't get it. We do the deltas correctly, right? Yeah, that's not the problem. New secret number, old price, new price. Well, it's time to debug, ladies and gentlemen. Right here we did do printf string d equals. Mierda, sorry. Yeah, this is interesting. I'm confused how there's a bug here. Append the deltas. Append here will do. Here was the secret number, comma k. Interesting. Okay, so yeah, we have pen prices of R, so yeah, 1 and 7. Basically, the question really is, what is going on with 2, right? Here what we need to do is, right, do this thing. We need to do 2 and 2000. Yeah. So yeah, here we want -2, 1 negative 1 3. I don't see any -2. So yeah, there's a crap load of numbers here. Well, here we can do print f string window equals. Right? Here we can do an exit. Two, 1, -1, 3. There is no such thing. Not tripping here, right? Changing 6, changing -1, changing -1. Yeah, 4 minus 4 is 0. 6 minus 4 is 2. 4 minus 6 is -2. What the heck? Maybe I need this logic, right? Let's make sure that my get next secret number is not messed up here. It's not. It's not the problem. Like, is it sure of its answer here? Test.txt. Oh. Nah. Mate, why did they change it? Bruh, they changed it from 110, 100, 2024 to 1, 2, 3. Okay, well, that's kind of evil. Okay. Well, that's kind of evil. Okay, let's put that in here. But also, still, that's not a... doesn't work. I'm confused, honestly, at this point. Oh yeah, one thing we can do for sure. Just comment this out. Okay, we can definitely afford to just not print. 779. So it did find it. I just done. Oh, is it just that the window is not large enough? I mean, okay, like, okay, well that makes sense. That's a little cheeky by them to do that. Okay, well we get 779. This is good. Nice. And why? Oh. So now what we'll do is this. This will be default addictive int. 23. Max key, max val equals none, comma, float of negative infinity. For key, comma, val in d.items. If val greater than max val, max key equals key, val equals val. Print f string answer is equal to max key. Yeah, -2, 1, -1, comma -3. Okay, 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 easy. There we go, there we go. Okay. And now if we put false, takes a little bit of a while. Okay, so it might take a little too long. Okay, no. We found an answer. How does it want the answer? Well, what's the most amount of bananas you can get? So here just return print f string answer equals max of d.values, which essentially is this one, right? So let's put a true here. Okay, we can also do a bit of cleanup. Update the window, add to current window. This is all debug stuff. Okay. Okay, this is good. Yeah, that's needed. That's very much needed. Okay. So if I do part 1.py. Okay, nice. If I do part 2.py. Nice. If I do false, then it takes a little bit of a hot minute, but you eventually just do get it. Right? Okay. So we get 1570. It took 8 seconds. Okay, submit. That's the right answer. Okay, you're 1 gold star closer to finding the chief historian. You have completed day 22. You can share this victory or return to your advent calendar. Okay. Ooh, okay, nice. You're starting to get the nice colors. Damn, I'm stunned. Okay, day 22 was way easier than day 21 and day 20 for me. Okay, I mean, nice. All right. I mean, I literally have day 21 still cooking up and processing the video because it's 6 hours long. And this one is going to be like, 1.5 hours or plus, like less than 2 hours long. Okay. I guess it still took a little bit of a minute. The thing that got me in problem day 22 was just the fact that this test data input was smaller than this test data, different from this test data input. That's what messed me up. And then when I tried to do it manually with the 2, I guess my terminal wasn't large enough because there was 2,000 things and it didn't print all of them, so it didn't show me the very first sequence it did. That's actually really, that's a little annoying, but oh well, okay. Well, it works out in the end. Okay, this problem was just a do this problem, and there you go, bada bing, bada boom, right? You just have to think of like, okay, use sliding window at some point, and that's pretty much it. I think like when the problems become like, their difficulty is like a little bit towards the LeetCode side, those are the ones that I like, right? Although I'm sure that like, everyone who did day 21 is like gonna be like, day 22 is a piece of cake, and there you go, right? Okay, nice, very nice, very happy about that. Okay, well, you know what? Let's go back in here. So as always, whenever we finish one of these problems, we'll eat one of our Advent of Code Advent chocolates. And I encourage you to have one with me if you've been following alongside the videos and having it with me every single time. So in case you are having a chocolate with me, then cheers to you, my friend, and let's go. Oh. Very tasty. Okay, nice. Okay, so as always, we'll make sure that we commit the fact that we did part 2. All right, part 1. Yeah, I don't mind adding that. Okay. 22, part 2 complete. There we go. Nice. There we go. Okay, so as always, in all my videos, I do a quick recap of how I was able to solve the problems. For day 22, this was really one of those, just do this problem, and here you go. I think they're giving us a little bit of a break from the monster that was day 21, which is nice. Very, very much well appreciated from my side over here. So essentially, you basically have a monkey that stole your banana and so on. Okay, I won't get into the nitty gritty of like, seller, buyer, this, that, blah, blah, blah. Essentially, you're going to be given a list of secret numbers. And essentially, from a secret number, you want to be able to generate a next secret number. And here it gives you a whole bunch of things of like how to compute the next secret number, right? It's like calculate the result of multiplying the secret number by 64. Then mix the result into the secret number. What does mix mean? Mix means like to mix two numbers means it takes the bitwise XOR of them, right? So here in my part 1 code, we'll just go this step by step. In my part 1 code, I have a mix function and a prune function. So mix and prune are two operations. Mix just means, okay, given two numbers, return to me their XOR. Prune just means given a number, give it to me modulo this value over here. That's it, right? Here's like, okay, calculate the result of multiplying the secret number by 64. Okay, so here we're gonna have a function called get next secret number from a secret number. Okay, we're gonna calculate the secret number times 64. Then mix the secret number into then mix the result of multiplying the secret number by 64 into the secret number. Okay, mix the secret number and the calculated number. Okay, then finally prune the secret number. Okay, secret number becomes prune of the secret number, right? And I just keep doing this, right? Calculate the result of dividing the secret number by 32 and round down to the nearest integer. Okay, calculate is a secret number divided by 32, rounded down to the nearest integer. Round the, that makes this result into the secret number. Okay, secret number is equal to the mix of secret number and the calc, right? And then prove the secret number. Okay, secret number is equal to proving the secret number, right? So it's very repetitive, right? And then calculate the result of multiplying the secret number by 2048. Okay, calc is equal to secret number times 2048, mix and prune, right? So here secret number is equal to mix of the secret number and calc, and prune the secret number, right? And then finally return the modified secret number after all this sequence, right? And so this is a function that takes a secret number, applies all the operations to get you the next secret number, right? So that's literally all this is. And in part two, you'll realize that you don't have to understand the way that it is. Essentially, this is just a more optimized version of the get next secret number from part one, right? But in terms of time complexity, they're both big O of 1, so there's really not much there to do, right? At worst case, you know, if you don't do this, it'll be twice as slow, and 8 versus 16 seconds, it's the same thing pretty much, right? So there you go. So if you understand this, then you know, perfect. So yeah, so that's just the function, and then we're like, okay, we now have a function that given a secret number can return to me the next secret number. Awesome. Okay, and it relies on this mix and prune. Okay, cool. Here we say, okay, we want to be able to get the 2000th secret number. So essentially what this guy wants is you're going to be given a list of secret numbers, and it wants you to generate the 2000th secret number from each. Simple enough. And then it wants you to take the sum of them. Okay, so what we're going to say is like, okay, literally for every number for every secret number in lines, right? So we're given an input, right? In this case, it's like, you know, we're given all these numbers in here. And so literally I say that's like, okay, for every single number inside of those lines, right, which is our secret number, if anything, I could have called the secret number, we're going to do get the secret number, get the 2000 secret number. So here we have a function that says get the kth secret number. So given a secret number, apply, you know, get the next secret number k times, right? So here it's like we want the 2000 number, so it's like we pass in 2000, right? It's just me being cheeky here, but the point is that we want the 2000 number. I was like, okay, might as well do it with a k. Basically, what I do is like given k, suppose k is equal to 2000 here. We're gonna say, okay, k many times, we're gonna say secret number is equal to the get next secret number, right? So we start with a secret number, then we're gonna say, okay, we want it to become the next secret number, and then the next secret number, and then the next secret number, 2000 times, so that way we have the 2000th secret number, right? So for, you know, we do a for loop that iterates k times, and over these k times, we keep modifying secret number to become the next secret number based on itself. And then at the very end, then we return the final secret number, which will be the secret number that is 2000 away from the initial secret number, right? And that's exactly what we want. So for every single number in lines, which is a secret number, we're gonna get the 2000 secret number. For each of those, we're gonna sum them all together. So like, you know, for 1 it'll be this, for 10 it'll be this, for 100 it'll be this, 2024 it'll be this. We'll take all those, you know, 2000 secret numbers, sum them all together, and that's our result, and that's literally what we return, right? And then I can just do this for part 1.py. You'll see that here I have a little timer to tell us how long it takes. So in 2 seconds, there we go, bada bing, bada boom, we literally get that answer right over here. Super straightforward. It's literally a just do this problem, right? Then for part 2, it's like, it's a little bit cheekier. I thought that, like, you know, for part 2 it would be much harder, where it's like, you know, you have to reverse engineer some things and so on. Not even. Literally it tells you, it's just, again, it's just more like, you know, tries to throws you off with some nuanced stuff, but it's, they try to make it sound scary, but it's not actually scary. So here it's like, okay, the way that a prior determines its price is like whenever it gets a secret number, like, you know, from 1 to 3, this is the next secret number, it just says, okay, the last digit is essentially the price. Okay, sweet. So here I have a function inside of part 2. First of all, get next secret number, I made a bit more optimized. Don't worry about that. You can use the same function for part 1. Here, get price from secret number. Literally, it's like, okay, get the secret number, convert it into a string, get the last character, convert it back to an integer, right? That's literally what I do, right? If I do Python 3, right, and then here's like lambda, get func is equal to lambda, you know, secret number, and it turns this into this. And then if I do func of 1, 2, 3, then the price is 3, right? If I do func of this number here, then I just get 0, right? If I do func of this number, like the point is just like, okay, you want the last digit? I'm too lazy. I won't even, like, you know, divide by 10 or whatever and so on. Not even. Straight up, just convert it to a string, get the last digit, convert it back to an int, done. Didn't even care about efficiency, right? Because it's like, why bother, right? Okay, so that's literally that. So I have a function that just gets the price from a secret number. It's literally just the last digit. However you get it, doesn't matter whether you do math or not, whether you do it cheekily with like me or not, doesn't matter. Here it's like, okay, One thing though is for part 2, essentially what they want is like, okay, from a secret number, the price is 3. What they want you to do is essentially compute the change in price every single time, right? And so here, from the next secret number, it would be 0. So from 3 to 0, the change is -3. Then from 0 to 6, the change is +6. Then from 6 to 5, it's -1, right? So essentially, it's like take the new price and subtract the old price, and that's the change, right? And so essentially, you can feed a monkey a sequence of 4 changes, right? So for example, you can feed it the sequence. What is the sequence example they give? You can give it the sequence -1, -1, 0, 2, right? And if you give it the sequence -1, -1, 0, 2, essentially what the monkey will do is it'll look at the buyer's prices and be like, until I see those 4 changes, I ain't buying. But as soon as I see those changes, I am buying, and I'm going to the next buyer. I am not looking at this buyer anymore. As soon as I find the sequence of 4 numbers, I buy and I get out, okay? That's just how the monkeys understand. Don't know why. That just is, right? So for example, here, -1, -1, 0, 2, here it'll look, okay, -3, 6, -1, -1. No, not interested. 6, -1, -1, 0. No, not interested. -1, -1, 0, 2. Ding, 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 ding. What is the price of this guy? It is a 6. I take that 6 and I yeet over to the next buyer. That's how the monkey brain works, okay? So essentially, in my mind, I was like, okay, if we have a list of all the deltas and all the prices, essentially we can just sliding window our way through, right? We're just gonna have a sliding window of length 4, and essentially for each one, it's like, okay, if this is the very first time in our current operation that we see this a sequence of length 4, okay, add its result, because that's what the monkey would buy, into a global dictionary where it's like, for this sequence, we're going to add that result. And that way, for every single buyer, we're going to add that result. If the monkey does that one again, blah, 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 right? And so essentially, we're going to say, okay, we're going to use the result of every single sequence that the monkey could have possibly seen. And out of all of those, we're going to return the one that essentially gave the maximum value, right? And so how do we do this? So here, very first thing is I have a function called get prices and delta. So given a secret number and an operation k is 2000, right? Essentially, I want to compute this list of 0, 5, 6, 5, 4, 4, 6, 4, 4, 2, as well as this list of deltas, -3, 6, -1, -1, 0, 2. And the way that I do this is very simple, right? So for all those k times, essentially I'm going to grab the next secret number. Simple enough. And whenever I do so, it's going to be like, okay, we have a function that converts a secret number to a price. The old price is the current secret number's price. The new price is the new secret number's price, right? And this is why I do k-1, because here I get the first secret number. So here's like, I've already done one iteration and so on. So that's why I do k-1 instead of k here. But that's just a minute detail. And here it's like, okay, once I have the old price, new price, and so on, okay, into the deltas, I'm going to append the new price minus my old price, right? So at the very beginning, for example, here, my secret number is going to be 3. When I do this, new secret number, get the next secret number. The next secret number I get is this, and then I'll convert it into its old price and new price, right? So this I'll convert it into its old price, which will be 3. This I'll convert it into its new price, which is 0. And here I'll say, okay, 0 minus 3, -3. That's what I append to my deltas. That's how you get this -3 into your deltas as the very first element. Then prices, I'm going to append new price because, okay, I'm going to append the 0, and there you go. So the very first element of prices is going to be the 0, and the very first element of this deltas is going to be this -3. Then when I go over, I say secret number is equal to the new secret number. Okay, so secret number is now equal to this guy, right? And then it's like, okay, when I go into the for loop again, I'm going to compute the next secret number. So from this one, it's going to compute this one. I'm going to get the old and new price. So the old price is now 0, and the new price is now 6. When I do deltas that append new price minus old price, I'm going to append 6 minus 0, which is the 6 that we wanted. And then I'm going to append the new price. So now we have 6 inside of our prices, right? So prices now looks like, 0, comma 6. And here we're going to look like -3, comma 6, right? And we can see like -3, comma 6, that's exactly what we wanted. 0, comma 6. How many iterations of the for loop did we do? We did 2, and we have 2 elements in each. So we want k, here the point is that we ignore the very first one, so that's why we do k-1. And so we'll just keep on going until we populate everything, right? And then once we've populated these prices and deltas, here's what we can do, right? Because essentially, given a secret number in k, now, by the way, I just returned prices and deltas at the very end. So essentially, I can take a secret number and a number k, so k is 2000. It never changes in this problem. I just made a k in part 1 because I thought part 2 maybe what make it you want to do up to the first 10 quadrillion, right? And I thought that you would have to maybe use some of like this manipulation here and realize some funny stuff and so on. And it's like, okay, you're allowed to do the up to the first 10 trillion instead of the first 2,000. Good luck. And it's like, okay, compute the 10th trillion secret number, do some math and whatever. No, it turns out not to be that way. But that's why I have K and so on. And because I thought, part 2 might be cheeky like that. And so I wanted to, try to get to part 2 as fast as I could. But yeah, it turns out to be completely irrelevant. K is going to always be 2,000, so I might as well even get rid of K, but oh well. So here, inside of compute, essentially what I do is, okay, given a secret number and a K, we're going to say, okay, prices in deltas equals get prices in deltas. We know how this works now, right? So it's essentially the prices will be like, 0, 6, 5, 4, 4, 6, 4, 4, 2. The deltas will be -3, 6, -1, -1, 0, 2, -2, 0, -2. And okay. And this is how this is going to work. We're going to have a global dictionary D, okay? Just remember this. This is a default dict, and it's of type int, right? Essentially, it's like, if you look up a number in there and it's never been called before, it'll have a default value of 0. So even if you do D of 4 plus or equal to 5, even though 4 is not in the dictionary, it'll initialize it with a value 0 be the default, then plus 5, and there you go. So you don't have to worry about whether key is in there or not, blah, blah, blah. Okay, enough yapping. The way that this works is essentially I build a window, right? And so the way the window is going to look at the beginning is like, let's do this literally, right? The window is going to be a double-ended queue. It's going to be the first 3 elements of delta. So here, let's pretend that our deltas is, -3, 6, -1, -1, 0, 2, and this is our prices, right? So the very first 3 deltas are going to be -3, 6, and -1. And here we see that we're going to append left garbage, right? So this is what our window looks like at the beginning. And then essentially for every single index from index 3, 0, 1, 2, 3, all the way up to the very last one, here's what we're going to do. We're going to update the window is step 1. What does update the window mean? Get rid of the thing at the left. That's why we have garbage at the beginning. We don't want to actually delete this -3. It's precious information. So we delete this garbage because we pop from the left, right? Boom. And now we also append deltas at index R. R starts at index 3, so this is index 0, index 1, index 2, index 3. So we put in -1 here, right? And so this is our current window. And you'll see that this is the very first sequence, -3, 6, -1, -1. And here we're going to have a visited set. So every single time that a sequence is visited, we're going to put that in our visited set because, again, the monkey, again, given a sequence, will look for the very first time the sequence appears and then never buy from the buyer again or sell whatever, right? So we only care about the first time that something happens. So here's what we do. So this is our current window. Here we're going to convert the window into a tuple because here we're dealing with a visited set in the dictionary, and a list itself is not a hashable type, but this is fine, right? Because the window is only of length 4 at all times, so converting a length 4 list into a tuple is constant time work anyways, right? So this is totally fine. And now if tuple window is not visited, then we'll add it into visit and do something. So the point is, again, for a specific window, this represents like, a window that we could have given the monkey, right? So like, for example, let's say we gave the monkey, -3, 6, -1, -1, and all of a sudden be like, I saw the thing that I looked at, right? If it ever happens again, we want to make sure that it doesn't include that price as well, right? So if it's the very first, how do we know if it's the very, very first time that we visited it? Well, if it's not invisited, right? Because every time that something is not visited, the very first thing that we do is we add it and visit it. So if we see it again, we know for sure that if we've seen it before, it's invisited and we can ignore it, right? So because we only go inside of here if it's not invisited. If it is, we see that we don't do anything, right? So if it's not visited, it's the very first time that we see the sequence of length 4, then we'll add it as visited. And here we'll say, okay, their dictionary of this tuple window, we know that from this buyer, the monkey would buy with this price, right? That's the good news. So for example, if -3, 6, -1, -1 was the monkey's thing, then here it would buy with a price of 4, right? Because this is index R is currently 3. Right, so maybe it's like, to make this clear, I'll do prices is equal to 0, 6, 5, 4, 4, 6, 4, 4, 2. Deltas is equal to -3, 6, -1, -1, 0, 2, -2, 0, -2. Right, we can maybe start moving some of these to match better. And then here we'll say, R is equal to 3, right? Which means that really R is at index, this is index 0, this is index 1, 2, and 3. So this is where R is, right? And so, so this is our current sequence, right? And so like, what is the price of this one? Well, it's whatever the price is here. So it's like, okay, it's the same price at the same index R, right? So in this case, it's like, okay, this is for a specific buyer, right? Because a specific buyer has a secret number, then it'll go up to the very first k times. So really this is compute per buyer, right? So this is for a single buyer, we're computing stuff. And inside of our global dictionary, we're gonna say, okay, since this is the very first time that we see this window, we're gonna say, okay, if the monkey's window was this, then it's like this is the value it would get, right? So how much it would buy for. So here we'll do plus or equal to prices of index R, so this 4 over here, right? And the nice thing is that every single iteration we're going to keep updating the window. Here it's like, okay, -3, 6, -1, -1. The next window would be 6, -1, -1, 0, right? So essentially it would no longer have this -3 and it would now have this 0, which is exactly what we're going to do. We're going to pop left, so we get rid of the -3. And we're going to add the 0 because here we dot append deltas of R, because now R is shifted by 1 because again we go up in the for loop, and now this is value 0, so that's what we add. Boom, right? And then it's like we're going to check, okay, if the tuple window is not in visited, then we add it in visited. In this case, obviously this is not visited. The only thing we've seen is this one, and it's not the same. So like, you know, 6, -1, -1, 0, this would give you a price of 4 as well, right? So here D of that window, we would increment by 4, right? And so essentially what we're going to do is we're going to do this compute function where for every secret number in lines, or for like every buyer essentially, we're going to compute with a secret number and 2000, right? And once we do that, essentially our dictionary will be populated with pretty much every single, you know, sequence of 4 deltas in a row that we've seen it in absolutely everything, right? And for each of them, it's like, since all we do is we keep adding the price the monkey would buy it at the very first time it sees it, if it happens for a specific buyer, the dictionary D will have for every single window essentially the total amount that the monkey would have bought out of all the buyers collectively with this specific sequence, right? So what do we want to do? Well, we want to get the value of the sequence that essentially gave the maximal value. So that's why here we return out of all of these values, right? So like, you know, it maps, like for example, you know, -2, 1, -1, 3 for this example would have yielded 23. So right in our dictionary it would be like, you know, this is the key, it would have value 23, right? So out of all the values we want to return the one that is maximal, because that's what the problem asks for us, and bada bing bada boom, that is literally it, right? So if I come in here and I do python3 part2.py, it'll take a good 8 seconds, I believe, but nevertheless, it'll do the solution, right? So here the problem is 1570. Let's confirm that what we get is 1570, and there we go. Bada bing, bada boom. That is exactly what we like to see, right? And so here I can even do a print f string D equals, right? And here we'll put in a true, right? Because here what we can do is be like, okay, -2, -1, okay, we'll get this guy, okay. So here we'll do right? And we'll see that this one is the value 23, right? And then this one has like, you know, value 5 and so on. So this one is the value 23. As we can see, if we come down below, the highest answer is 23. And like, so yeah, so this is one of the keys that has the highest answer, right? So of all the keys, right? For example, this key would give 23 bananas and so on. Every single key has like a unique number of bananas it would produce, blah, blah, blah. So we essentially return the one that is maximal, right? Because it's asking you what is the most bananas you can get. Well, like for example, with this key, you could get 23. And sort of all the keys, you want to return the one that will give you the most bananas. So that's why we return max of d values over here. So hopefully, that solution makes sense. And yeah, but otherwise, that is pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I'll catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.